nice thing about binomial distributions is that there are shortcut formulas for the mean and standard deviation that don't require us to build the entire table and do that math with additional columns. If I want the mean for a binomial distribution, that mean is going to be equal to the number of trials, n, times the probability of a success, p. For the standard deviation of a binomial distribution, it's going to be the square root of the number of trials times the probability of success times the probability of failure. And for binomial distributions, we should know what n and p are when we start the problem. And if we aren't given q, we know q is 1 minus p, so we can figure it out. So when we're working with binomial distributions, we often don't have to construct the distribution table or the distribution function in order to answer questions. So let's go ahead and do an example. This one says, a fair coin is flipped 4 times and the results are tallied. We want to keep track of the number of heads that occur. Construct a binomial distribution for this binomial experiment. Calculate the mean and standard deviation of this distribution. Is the mean what you expected? Explain. So let's go ahead and work through the problem, and we'll actually do B before we do A, because I want you to see that we don't need the table in order to do these calculations. So first thing I notice in the problem is that we want to keep track of the number of heads. So that's our variable of interest. That's a success, which means my number of successes are the number of heads that occur. I also see that we're flipping the coins 4 times. Remember that the number of trials is what we're calling n. So they have told me for this experiment that n is 4. I also know that when I flip a coin, there's only 2 sides, and if that coin is fair, the probability of getting heads is 50%, or 0.5. That also means the probability of failure is 0.5. Those 3 pieces of information are enough for me to skip to step B without having to build my table. So let's do the calculations first, and then we'll come answer that second question after we build the table. So for the mean, we know the mean is number of trials times probability of success. So 4 trials times 0.5, which I happen to know is 2. So what that means is if I flip 4 coins and I keep track of the number of heads, and I do this over and over and over again, the average number of heads I expect to see out of 4 coin flips is 2. For the standard deviation, we're going to do the square root of the number of trials times probability of success times probability of failure. So the square root of 4 times 0.5 times 0.5. I'm going to go ahead and grab my calculator for that one. So second square, 4 times 0.5 times 0.5, and we get 1. So we expect that the number of heads are spread pretty tightly around that mean of 2. Now let's go ahead and look at what a probability distribution would look like for this binomial experiment. I know I need a column for x and a column for p of x for probability distributions. I also know that the smallest number of heads that I can have would be no heads. That would be all tails. The maximum number of heads I can have is 4. That means all 4 flips were heads. So I should have numbers between 0 and 4 in my table. To figure out the probability, I'm going to go ahead and look at what this sample space looks like. And this is the tedious part. I think the fastest way to do it is to build a tree diagram. I'm making 4 flips, and I'm going to build my tree diagram sideways. So I need a section for the first, a section for the second, a section for the third, and a section for the fourth. So that first split, I know that I could get a heads or a tails. 0.5, 0.5. I know for my second split, I could get a heads or a tails. For my next split, I could get heads or tails for each of those. And then my last split is going to do the same, and I'm going to make these a little bit tiny here. So I'm going to count the number of branches in that fourth chunk of my tree. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know that all of my fractions are going to be something over 16. And then I'm going to come along and I'm going to write out what those 16 outcomes are. So if I follow that first branch, that's a head, 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 head. So I could have H, 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 H. Next one is H, 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 T, H, 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 T, and then H, H, T, H. And then H, H, T, T. So that takes care of those 4 branches. And then we'll do, that got that, okay? Then we'll follow the next, which is H, T. I'm gonna have 4 guys that start with H, T. And then I have H, T, H, H. And H, T, H, T, which is that guy, and then H, T, T, H, which is that guy, and H, T, 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 which is that guy. That branch is done, so halfway done. I'm going to list the other half down here. So the rest of this is all going to start with T's. So 1, 2, 3, 4, 5, 6, 7, 8. And then I know my first branch of the T's is the H branch. So 4 of those are going to have H as my next. takes care of that, and then these would be T, 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 T's takes care of that, and then we're going to go the H branch, H, H, and then HT, and then we'll go the T branch, and we'll have TH and TT, those two, and then we're going to have an H, H, and an HT, and a TH, and a TT, which are those. And now I'm going to go through and classify. I'm going to do the first and last row first. Those are going to go fastest. So for 0, I'm looking for no heads. That's this guy here. There's one of those. So that's 1 out of 16. Whoops. 4 is very similar. I'm looking for all heads. That's up here. There's also one of those. Next, I'm going to go through and pick off the guys that have exactly 1 heads. We'll do those in blue. So I'll start down here. This guy has 1 H. This guy has 1 H. This guy has 1 H. And then 2, 2, 3. That guy has 1 H. And I think that might be the last. So I see 1, 2, 3, 4 blue dots. And then I'm going to go back and I'm going to do the ones that have 3 H's. So 1, 2, 3, 2 H's, 2 H's, 3 H's, 2 H's, 2 H's, 2 H's. So I count 1, 2, 3, 4 green dots. And then everything that's left should be 2. Or, yeah, 2. So half and half, half and half, half and half, half and half. 2, 2, and 2. And I'm going to count those orange dots, and I see 6. So I'm going to double check that I did it right. These should add to 1. So I have 1 plus 4 is 5, plus 6 is 11, 15, 16. So 16 16ths is 1, that checks out. The other nice thing you'll notice about this distribution, nice, pretty, and perfectly symmetric with the peak at 2 in the middle, and then 4 and 1 on either side. And look at where our mean is. Our mean pops up right smack in the middle of that symmetric distribution. And I can see it's tightly packed because most of the data is either at 2 or on either side of 2 at 1 and 3. When I see you in our next video, we're going to talk about how to find these using a calculator. Remember that for calculating mean and standard deviation, we can do it without the probability distribution. As long as you know N, P, and Q, those shortcut formulas will get you that answer without having to build the table. If you have any questions, feel free to drop by my office hours on Thursday or send me an email. Otherwise, I will see you in our next video.